And what we're going to be doing today is we're going to be diving deeper in stats. Right, previously we did an overview of Excel, and now we are going to actually get into something more statistics. This is a day that we purely are just going to be working off the board. So one of the few days where I don't have any Excel stuff at all. But you know, if you want to play around with Excel as a doc, that's fine. Okay. I think the first question that we should ask ourselves is, what is, so we talked about before what statistics is, and statistics often deals with what? Numbers, numbers about a sample. And how many of you have heard of the term sample before? All right, most of you, I would hope so. So then you should be able to tell me what a sample is. Can you tell me what a sample is? Yes. Oh, yeah, it's a portion of the population. So you hit on two ideas. So one, you brought up this idea of population, which is really important. And two, you called a sample a proportion, I like to say a subset of a population. So what is a population then? Subjects of interest, right? All possible subjects of interest is how we actually do this, right? All possible subjects of interest. Subjects of interest. So, for example, if we are trying to find a new treatment for a disease, like say the coronavirus, right, or a cure for it, or for cancer, or whatever else, it's not merely that we care about the people, seeing if the people who are in our sample survive. Who else do we care about? Exactly. In other words, all the people who are sick as well, we're now in our population, or now in our sample, all those people too. Right? We're checking the sample for all people we care about, for this larger population. And it's not merely the people who are even currently sick. We're technically also checking for the people who could be sick at a later date. For something like cancer, if we're checking to see if a cure works or a treatment works or is effective, we're checking for people maybe who aren't even born yet, who could get cancer later in their life, right? All possible subjects of interest. It's not like when you get a flu vaccine and they're like, yeah, but you weren't born when this was tested, so they weren't including you. It's like, that's what we're concerned about. So that is the population, all possible subjects of interest. And the sample is just a subset of that population. And this is going to be a big theme of what we're talking about today. A good sample, what? What do you think? A good sample begins with an R. Exactly. A good sample is representative. A good sample represents the population. It's not enough for the sample to be a subset, right? That's really easy to do, but it has to be a good sample. It has to represent that population in some way. That's the goal. Some terminology. We call a parameter a notable characteristic about a population. Parameter is a notable characteristic about a population. A parameter is a notable characteristic about a population. There's also a term to describe a notable characteristic about a sample. I might have to edit that out. So we also have something called, we have parameter, notable characteristic about population. What's a notable characteristic about a sample? Statistic. Hey, how'd you know that? You took stats, right? And so you remember this part. So I like to sneak that in, because of course, that's what we're taking. What are we taking? What is this class? Statistics, right? In other words, it's called in statistics in part because we work with statistics. We don't work with parameters. We often don't know the population. We don't know what the population average is. We don't know what the population standard deviation is. If we did, we wouldn't need the sample. The point of the sample is to inform us about what's actually going on. Right. That's why we call it statistics, because we work with statistics. We work with these characteristics about the sample. We work with samples. Okay. So this leads to a natural question. Why sample? I mentioned this a little bit. We should probably emphasize, why do we bother sampling? Anyone? Yeah.
It would be impossible to collect data from like literally the entire population.
Yeah. So there's a lot of answers that kind of overlap a little bit.
But one, probably the biggest one, it's practical, right? We can't, now granted, there are some populations we could draw from, because population is a kind of fuzzy thing, right? It's whatever we find interesting, whatever we care about. So if the only things we care about are current Montgomery College students, then it is possible to survey all Montgomery College students. If we want to know, for example, the GPA, the average GPA of all Montgomery College students right now, could we get that entire population? Right, absolutely. Right, absolutely we could. Yeah, we have that data, right? It's in our database. Right? It's a simple keystroke to figure it out. But you're right, generally we are working with something larger. We have to take a sample. One example of this, how many of you drove to get to campus today? All right, now of course driving is a very dangerous thing, often the most dangerous thing people do every day. So it's a good thing that your car was what? I think I heard it. They do this with every model. The company does crash tested. It's a good thing your car was crash tested. Now, do they do a sample when they do a crash test? How do you know? Exactly, right? They have to do a sample when they crash test. If they check the population, because the population they care about, all the cars they sell, if they check the population, they would crash all the cars. And they would not have any cars to sell. So you naturally have to do samples, right, in cases like that. Or in cases like testing people, right? You can't test people who, you can't test for disease, or you can't test if this works or not as a cure for people who don't have the disease yet. So it's practical. It's a very basic level. We have to sample. Right. It's also cheaper for the obvious reason that you are not testing everyone. Faster for literally the same reason. And because it's cheaper and faster, it unlocks the ability of something you normally can't do. Let's imagine, for example, I wanted to know everyone's favorite color. What's your favorite color, Dennis? Red. Favorite color? Red. Favorite color? Blue. Really boring. Blue. Right. Now I could do that if I wanted to know the favorite colors of the entire population of Montgomery College, then is that like How long would that take? Right, a lot of people to ask. If I only do a sample, though, it's going to take a lot less time, right? It's going to be faster, it's going to be cheaper to only ask those people, which unlocks the ability for me to ask more questions besides just your favorite color. I can figure out, I can ask you your age, I can ask you your gender, I can ask you your major, I can ask you a long list of things. And then that allows me to see how things connect. They do this all the time when they're doing polling, right? We're in election year, they do polling all the time. And you get information about, like, which age group prefers which candidate, or which gender prefers which candidate, right? And they can do that because they ask a lot of questions for one particular person, right? So because you are cheaper, because it's faster, you allow for greater depth. Allows for greater depth. And you can really drill down and learn a lot of interesting correlations and connections that you normally can't if you just tested everyone, because you wouldn't have that kind of time.
Okay. Any questions?
So, because I'm recording, I'm just going to stand this down. I know it's annoying, but everyone has this.
Where's your camera?
So the camera's right there on my computer. And so I, like, before class, I check to see where where I can see. So is this, I mean, if it's annoying, I can just go without it. I can just move my computer. I just don't want to lose my alignment. Okay, great. This I might miss something. This is also why, by the way, I put this online for you, so that, I feel like it's kind of compensation for having to suffer through the way I do this. Okay, so we need to think of what a good sample is. So to start with a good sample, it's helpful to compare it to the optimal way to gather a sample. Obviously, a sample is a subset of the population. It depends on how we gather it. So the gold standard is what's called a simple random sample. By the way, what is more visible, the purple or the black? Which do you prefer, purple? I like purple, so thank you. Okay, well, that makes me happy. I like the purple. So the simple random sample. Has anyone ever heard that phrase before? Simple random sample. Yes, Dennis. What is that? What is it?
Like, simple, right?
Yeah. Like, I can't just.
Okay. Anyone else? So I know some of you have static, maybe this is familiar, kind of something. Yeah.
There's no like specific way of doing it. You kind of just go out and go like this person, and then maybe that person, and maybe the other person.
Right. I mean, there's a lot of ways to achieve a simple random sample, but the definition is precise. And it's every element in the population has an equal chance of being included in the sample. That's what we mean by a simple random sample. Remember, a sample is a subset of the population, which means some parts of that population are going to be included in the sample, and some, and quite frankly, most will not be. So we need some way to figure out what do we include and what do we not include. And a simple random sample is a situation where you just make it equally likely everyone included. And if you say some are going to be more likely to include than others, you've got a problem. Then you run the risk of it not being representative. But a simple random sample, we can set that up. So this is what, when we have enough control, this is what statisticians do. Sometimes, for example, they're like cities might do tests to figure out if a policy works well or not. And they might have a group of people who say qualify for some benefit, maybe some unemployment benefit or something. And they want to know, like, well, what would happen if maybe they got housing assistance instead of cash? Or maybe we give them some worker training instead of just giving them cash, something like that. Then they can take all this group of people that are going to get this housing assistance and randomly assign, some of them will get the intervention and some of them won't. And that would be a simple random sample. Maybe they do it with everyone represented by a deck of cards, and they shuffle it really well, and then they divvy it out. Or maybe it's just organized alphabetically or something, and then they just pick people at random, however they want to do it, names in a hat or something like that, or however it's done. But if you can set that up, it's always not possible to do this because you don't always get to choose who's included and who's not. But if you can do that, that's a simple random sample. Right. Everyone has an equal chance of being in the group or not. They do this often too with medical testing. You know, you have a group of patients, we need a control, we need a treatment, so you will be randomly assigned one or the other. You won't know, it's double blind, but you will be randomly assigned. Like I said, it's hard to do this in practice sometimes, but it's useful to recognize what our gold standard is, because then we can compare whatever we're doing with that. We have something to shoot for. Questions? Great. So a good sample is, actually, so I'm going to include it over here, has two basic qualities. One, it is precise. I picked 3 people to figure out what their color was. It was red, favorite color red, favorite color red, favorite color blue. Imagine I stopped there and I said, I guess 2/3 of people like red. 2/3 of Montgomery College students like red. 2/3 of this class like red. So that 2/3 of this class like red. 1/3 likes blue. What would be the problem of me doing that?
The elements don't have an equal chance, so this doesn't actually have a proportionality to the class.
Well, so I would argue that maybe they did, because I mean, maybe there's a connection between where you sit and what your favorite color is. But I would say I essentially did choose them randomly, just choose people over here. Maybe I didn't disperse it, granted, but so you could argue that it wasn't truly random, was it truly simple random? But I think you're sort of hinting at the deeper point that there is a problem with this. You said how many people?
So, yeah, so it's 3 people out of how many people we have, and also you only have 3 colors, or 2 colors on the board, but there's where you get 7 colors.
I mean, there's more than 7 colors.
Well,
I don't know what world you live in, but I know what you mean. I know what you mean.
Yeah.
I know what you mean. Right? Like, I can't possibly include all of the colors if I only look at 3. But this issue of I'm only looking at 3 is a problem, because by random chance, maybe I just got people who are fans of red. Maybe if I check everyone else, it turns out red only happened 2 times. In other words, whenever you sample, you're only going to be including, by definition, some subset of the population. And by just random chance, you might get something weird. Even if it's a simple random sample, you might get something weird. If I picked them at random, I might have only gotten people that liked red. That's entirely possible. So how do I fix that?
How big is the sample?
Well, that's my question. So how would you fix it?
So if, let's say, if everyone only liked red, all they need to expand your sample of people you asked.
Right, exactly. Exactly. So my problem is essentially only has 3 people. A sample is precise if it minimizes error. Due to random variation. No sample is perfectly precise.
There is always going to be some chance that you got a weird sample, just by randomness. But you can minimize that chance by increasing your sample size.
Sampling error can't be avoided. No sample is perfectly precise. Do you know what is perfectly precise? Anyone? Do you know what is perfectly precise? Do you know what has no error in it at all? Begins with a P. Yeah, kind of like that. Why do you say census?
I said that. It takes the whole population.
Yeah, exactly. Right. If you check the whole population, then there's no chance that no one is not included by random error because you literally checked everyone. Right. That's why I like census. Perfect. It's a great example, right? The census checks everyone. Granted, it is not literally possible to check everyone because some people don't, they don't fill it out, whatever. But generally speaking, at least on the goal, is to check everyone. So populations are perfectly precise. Of course, as we said, population are always possible. Bigger samples mean more precise. Why does that make sense? Why does bigger samples means it's more likely to be precise, or it's more precise? Yes.
Well, you're trying to produce like a sample of sample, then you're definitely going to get more people because there won't be there will be more variation and you won't have much of the same people answering the same question, so you get like different answers.
So say that again. So
No.
no. What? I'm sorry. What?
So when you ask for precision, you probably want to have more people involved in the sample or whatever you're doing because you want more different types of opinions. And
True, so you're absolutely right that we are, and if we get more people, then we're naturally going to be able to get more opinions, right? I can't have 8 colors when only has 3 people. But there's this related issue that I want to make sure we understand.
If I only ask 3 people, are there pretty good chances I'll only get red as a favorite color? If I ask 30 people, what are the chances I'll only get red as a favorite color? That's a lot smaller, right? It's like the difference between flipping a coin twice and getting heads twice in a row, or flipping a coin 100 times and getting heads 100 times in a row. Right? It's just less likely that I will get that sort of unrepresentativeness. Not only, as pointed out, I will get a broader range of colors in all likelihood, because it's actually capable for me to include more colors if I ask more people, but it's also less likely I'm just going to get weirdness just as a matter of basic probability. We follow? Yeah, great. So bigger sample size, I should say bigger sample size, just to emphasize, means more precise. Can you read this, by the way? Am I making this too small? Sample size means more precision. Okay. The thing about precise, that all samples are precise, is that it's a straightforward thing to check. You look at the sample size. Some people say a sample size of 30 is a good sample size. I say it kind of varies based on what you're actually measuring. Like, as noted, if there's a lot of variation in the population, then you probably need a larger sample size to capture that variation, to be able to capture it. Things like that. But generally, if you're looking just a really basic idea of what's a good sample size, I don't really know, 30 is a good starting point to think about it. When they do polling to figure out like what people like, they might talk to 100 or even 1,000 people. So they're trying to make sure it's really good. But I don't like drawing clean lines. 30 is good, but 29 is bad. That seems intellectually sloppy. It's not good. So this is relatively easy. If you see it's really small, like 10 or 3, then the solution is really easy. Increase your sample size. Done, you walk away. As a side note too, a lot of psychology experiments, a lot of experiments in social science, but a lot of psychology experiments run into this issue. They can't be repeated. They might like run an analysis based on volunteers who are doing these things, and then it turns out that they can't replicate the results. And it seems like the reason why is because they're working with small sample sizes. Why do they work with small sample sizes? Does anyone know? Out of side note? Yeah?
I would assume that it's harder for psychologists or psychiatrists to spend as much time analyzing a person if they have to do 30 or 60 people instead of 15 or 20.
Yeah, exactly. So part of it is the constraints that they're often working with a student body, and so they have to get volunteers to do this. But this other part you're talking to is like, sometimes their experiments are just really involved. And you can't like have 80 people in the sample in the study. You can only have 10. And so like, I guess we'll try to work with 10. And unsurprisingly, it's hard to replicate those results. The subtler issue, the other problem with samples, the other thing a sample has to be is accurate. And inaccurate samples are what we call biased samples. A biased sample is one that systematically underestimates or overestimates the parameter. Remember, all samples are trying to estimate the parameter, what's actually going on. Biased samples systematically under or over estimate the parameter. Yeah.
So when we're talking about accuracy, it's about saying like whoever's doing the research has to try not to be, I guess, prejudiced or biased in any way who they sample or what they sample.
Yes, but it's even deeper than that. It's not merely a personal bias, but it's a design of how we gather the
So
sample.
it's not the same as like precision per se.
Yeah, it's not the same. So precision is like totally random. It's like you can't avoid it. Here, this is more like, we'll talk in great detail about the ways that it can be biased, but we're talking about like, if I were to gather this sample multiple times over and over again, I would generally always get too low of an estimate of the average or too high of an estimate of the average. So like if I wanted to survey people in this room, what job would you like to have after you graduate from school, after you get done with your degree? What job would you like to have? Anyone want to volunteer what they might think? What job would you like? Where would you like to work? I'm just going to start picking people then. Audrey.
I have no idea.
No idea. Okay. That's fine. I feel like I get a lot of those. This might not work out. Miranda.
marketing directors. That's when I ask people what they would like to do. Right, Destiny. No idea. Now, if I keep doing maybe get marketing director, how many of you are interested in accounting? Maybe want to be an accountant? Literally, okay, 1 or 2, right? Now, if I were to, how would this compare with the larger school? Well, people who don't really know, people who maybe want to go into marketing, sometimes maybe people want to do sales, advertising. I get a few of those, accounting. What portion of that do you think would compare to the rest of the school? Yeah. Exactly, right? This course has a lot of business majors. How many of you are a business major? Raise your hand. Virtually everyone. Right? So that is going to bias my results. If I were to check this with a different section of BSAD 210, if I were to do this year after year after year, I'm always going to get a lot more people interested in marketing and accounting than I am going to get people who want to do nursing. Right? My sample is biased. My sample system of trying to figure out what Montgomery College students like by asking only this course is fundamentally flawed. And I am always going to way overestimate the number of people who are interested in marketing and way underestimate the number of people who want to go into nursing or engineering or psychology or social work or something like that. Are we good? Okay. So, let's talk about how good samples go bad. Because this, like I said, is obvious when it screws up. It's pretty straightforward. Accuracy is a sneaky little mistress. And it can sneak into lots of different places. It's a lot harder to detect beforehand. This one that I gave you, though, this example I started with, is a straightforward enough one. And we call it, oops, I want to keep on the purple because people like the purple. Undercoverage bias. So this is, I knew this is slightly different order than my notes, but that's just how it worked this time. Undercoverage bias. That's fine. Undercoverage bias occurs when certain elements in the population cannot be included in the sample. And I'm gonna underline that cannot be. By the design of how I'm gathering the sample, there are certain people who cannot be included. Like by the fact that I'm looking at BSAD 210 students, staff students, I cannot include people, or I mean I cannot, but basically functionally for all purposes, cannot include people who don't need to take this course. Because they're not going to take this course unless they have to. They're going to take this course unless it's a requirement. In order to make undercoverage bias happen, though, those who are included must be different than those who are not included. Justin, why do you think that my estimation of job aspirations is my method, by checking on this class, is a better way to estimate all of Montgomery College. What's your major? Business. Do you think most people here are business? Right. Yeah. Do you think business majors want certain kinds of jobs? Do you think those kinds of jobs tend to be different than people who are other majors? Boom. I'm only asking people who are probably going to go to certain kinds of jobs. That is systematically different than the larger population of Montgomery College, who might go into all kinds of different things that are not related to business at all. Is that clear? When I checked for color, favorite color, was that a problem? That I was only checking business majors? No, why not, Audrey?
Because you don't have to be a business major to like a certain color. It can be anybody.
Yeah, there's probably no correlation between what I want to do for a living and what my favorite color is. And that reality puts the bias, or in other words, takes out the bias here under coverage bias. Yes, I'm not counting people who are not business majors, or specifically who are not taking stats, because we have obviously non-business majors who are here and business majors who are not here. But obviously I'm not including people who are not taking this class, but I don't think there's any connection between taking this class and liking the color red. All right, it's not like by asking people only in here, I'm excluding a whole bunch of people or disproportionately a whole bunch of people who love purple. I don't think that's happening. Right? Maybe there is, right? But in all likelihood, it's not. So it's not enough that you're not including certain things. There has to be some sort of bias built in. There has to be that the people who are excluded are fundamentally different than the people who are not, who are included. We're good on that?
That's where it's be under.
Yeah, that's going to be under coverage bias.
Right. It's not enough to say you're not including certain people. You're not allowing certain people to be included. You have to come up with a reason for why it matters that you're not including them. So during the 2016 election, as you probably have heard, this is like probably ancient history for you guys now, but as you might have heard, the polling was really bad for that, and everyone thought that Hillary Clinton would win, and they were wrong. The polling was off. Now, why do you think that happened? Anyone ever heard? Let me tell you one theory as to what happened, and then there's very evidence that this happened to a certain extent. A lot of polls relied on landlines. Does anyone know what a landline is? Just making sure, just in case you don't know. So this is a landline, right? It's a phone that's physically attached to the wall, and then when you pick it up, you get a dial tone. Right. There's a lot of data like this used to be the standard for how you contacted people. Is you pulled out, you have a bunch of these landline numbers. They have whole databases of this, and they call them, and they call them all the ones that they have, and then they ask them who do you support. They did not call very many cell phones. How many of you, by the way, have a landline at home? Just a couple of you, maybe about, what, 20%? Yeah, it's very uncommon, right? We don't have one either, right? What do you have instead? Yeah, you have a supercomputer. Usually said you use a cell phone, right? And they did not have enough of these numbers, essentially. And so that threw it off. People with cell phones were far less likely to be contacted. People who relied on cell phones were far less likely to be contacted than people who relied on landlines. And that threw off the numbers, right? Because the people who relied on cell phones were different than the people who relied on landlines. Right? Under coverage bias. They did not include certain people they should have included. Okay. All right. Let's do another one. Let's do one that's we'll get related to that. No. I'm gonna do something that's similar to it. Survivorship bias. So Let's imagine we were curious how good therapists are. How do we measure how good a therapist is, or how good therapists are in general?
Review.
What was it?
Reviews.
There are reviews online. So, but, you know, and something we'll talk about is there's a problem sometimes with the reviews, like as people are opting in, and then maybe there's something weird about people who are opting in. We'll talk about that in a moment. Let's imagine that we wanted to maybe confirm to see those reviews are good. And so we are just going to ask patients. Like we have a database of patients, and we'll just ask them at random. But maybe we have a problem. Like, if you go to a therapist, you don't really know how good the therapist is after the first session, right? You don't know if they're there for you. You don't know if they can help you solve the problems. It's just very introductory and preliminary. They don't know how consistent the schedule is or whatever it is. So maybe we don't want to rely on people that have only been there once. They don't have enough information. But they probably have enough information after, what, like 6 months? So we're going to ask people, how do you rate your therapist? And we're only going to ask people who have been with their therapist for 6 months. What's the problem with that?
You don't have your, like, exact response to that question when they first start out. So
Yeah.
you have nothing to compare it to. So
Right.
you can't see if they've actually been a good therapist and they've evolved and progressed in their treatment.
Sure. So we don't have any idea on like if the therapist got better or not, or if the patient got better. But I just want to get their opinion. I just want to know if people like the therapist and how well they rate them. Yes.
I mean, generally, consumers always speaking to a therapist for a certain amount of time, they probably like the person.
Right? Is that what you're going to say? Yeah, absolutely. Right. We have a problem here. It's that the only therapists who actually get surveyed are the therapists that people have decided to stay with. It's only the therapists that have essentially survived this little process that we created by requiring 6 months. In other words,
We have a bias. We concentrate on observations that endured some kind of
process. Endured some process that endured or survived, is where it comes from. And the survivors are different. Than those who didn't survive.
A therapist that sucks will have a constant stream of patients who stay with them for a little bit and then say, screw you, you keep throwing things at me during our sessions, right? I don't like that. And they're never there for more than a month, and certainly not for 6 months.
And this therapist never gets evaluated because this therapist never survives that 6 month evaluation format.
And so now you see we haven't been attention as far as solve. The whole point of putting this 6 month requirement is that we can then be confident that the person knows enough about them. Maybe 3 months would work just as well, or even maybe 1 month, but they still have to survive for 1 month. So it's a really hard thing to solve.
But again, note the key idea, just like here, those that survive, those that are included, have to be different than those who didn't. Any questions?
What's the difference then between these two? Because they seem really similar, right?
What's the difference between these two?
undercovers would only apply to like your original sample, and like survivorship, it doesn't include the full original sample.
I like how you're thinking about it, because you're thinking in terms of that original sample, of like what we're, but keep in mind, we only have one sample each time.
Yeah.
But that sort of, I think I see what you're getting at, and I'm gonna try to fill in, this is a bit of a tricky question. So here, we know ahead of time who won't be included and who will be. Right? If I only survey this class, I know immediately I got a problem because I'm not including people who don't take this class. Here, I don't know ahead of time. I don't know ahead of time which therapist is good and which therapist is bad. Right, that's why I'm checking in the first place. So here, you know who you'll exclude beforehand. Here, you know who you excluded only after the fact. Another example from economics is minimum wage studies. So, what? Oh, okay. Another example for economics is minimum wage studies. We will check to see how many employees a company has before the minimum wage goes into effect, and then check to see how many employees companies have after the minimum wage comes into effect. But it's hard for accounting purposes to check the same company over and over again because they don't always fill out the surveys and everything, so we just poll. The problem is, after the minimum wage comes into effect, the only companies that are around are the companies that survived the minimum wage. If a company closed because it couldn't afford to pay its workers anymore, we won't be able to count it because we can't survey it anymore. And that biases the results. That's why sometimes some poorly designed, there's like tons of minimum wage studies. Some poorly designed minimum wage studies in this way, unsurprisingly, find no effect on the minimum wage because you're only counting people who survived. You're only counting companies that survived it. But we, of course, don't know which companies will survive beforehand. Right. Any questions about this distinction? No? Great. Last one. Self-selection bias. How many of you have ever watched cable news? Raise your hand if you ever did. Oh, you poor folks, why do you do that? It's like they just don't have anything to talk about most of the time. That's fine, however you want to spend your time. Now, have you ever seen them do like a poll? Sometimes they'll ask like, hey, yeah. And then you can go online and you can see, and you can participate in the poll. And they might mention that at the beginning of some show, and then they'll give you the results at the end of the show. Have you ever seen anything like that? Sometimes they do that, right? And what do they say at the bottom? Yeah. Right, exactly. The people who participate tend to have a very strong opinion on one side, right? That's why it always says at the bottom, at least it should say at the bottom, not a scientific poll. Because these polls have two problems. What are the two problems with these polls? One is one we've already talked about. Only the people who are watching the show know that a poll is going on. If you don't know a poll is going on, you can't possibly participate. So there's undercoverage bias. But there's, as you point out, another kind of bias. What did you say again? Exactly. The only people who really care are going to participate. And they're probably, maybe they care about some weird thing, and that's going to throw things off. So there's also a self-selection bias in here too. That's what we call self-selection. When the actual components of the sample choose if they're going to be included or not. observations decide if they're going to include or not. This becomes, self-selection happens a lot. It's hard to force people to say take polls, but the bias comes in just like before if those who choose to be included are materially different or different in a way that matters, then those will opt out. I say in election notes, I mentioned always this idea of like there's a bias, there's a non-random element. That's what this is getting to, this section right here, or right here, or right here. It's not merely that there is this distinction, it's that this distinction results in some sort of systematic error. People who are included are different than the people who are not included. People who survive are different than the people who don't survive. The people who select in are different than the people who opt out. In some material way that matters. So, as you know, the people who tend to do these polls tend to be really opinionated, or they might be more prone to freak out about things, and you're going to get some, depending on the question, you're going to get some like weird answers. Any questions? I want to emphasize this idea of self-selection bias because it comes up in a lot, and I don't want you to too easily dismiss it. So how many of you use Rate My Professor, for example? Many of you do. Many of you. Now, does Rate My Professor have a self-selection bias problem? I see everyone nodding their heads. Why? Why is that? How many of you use it? Like you said, all of you use it. Why do you use it if you know that there's going to be a bias? Yeah?
So at the end of the day, the professor had a lot of bad reviews. Clearly he's not a professor.
So in other words, what you're saying is there is no bias.
Correct.
Yeah?
So the sample size, so if they have like 2 or 3 reviews, I'm less inclined to believe those reviews if there's 7 or 8 to 10 of bad reviews. So if there's long laundry list of bad reviews, I'm more likely to believe all of them than if there's like 2 or 3.
So Lauren, you're pointing out this idea of precision. That's good, right? So you ignore someone who only has a few, but it'll mean a lot more if there's a lot of bad ones, right? And that's good. You should absolutely do that. That matters a lot. But this other issue of you say, oh, people select in, and that's true, they do. But as you note, the poorly rated professors, assuming they have a lot of observations, assuming they have a lot of ratings, are probably pretty bad. And the ones who are rated pretty well are probably pretty good. And the ones who are okay are probably okay. Right? Is that what you find? Right? I assume so because you keep using it. So on one hand, we want to say, oh, there's self-selection because people choose to rate or not. At the same time, at least the averages seem to be doing a pretty good job. That the people who choose to be included are probably not that materially different than the people who said, never mind, I don't care. How are you saying that they're different again, if you have a strong opinion? So who does not use Rate My Professor? Like, are you saying you don't, or are you saying that are you answering my question in general? You don't, but what kind of person doesn't? What kind of person would not use the site? Yeah?
A person that's probably not going to be really concerned about the teacher versus like the content that they're reading. So if they're
Yeah. People who are just like, eh. Right. In other words, people who don't have those strong opinions. Right. So, in other words, people who have strong opinions, the positive way are likely to rate. People who have strong opinions, the negative way are likely to rate. And that kind of cancels each other out. So if there's a lot of people over here, because the professor's bad, it's going to cause them to have low ratings. There's a lot of people over here, because the professor's pretty good, it has them to have high ratings. And then that's kind of why it balances out. It's a pretty good estimate for the population average. It's a pretty good estimate for what how good they are on average. It is not a good estimate of the dispersion. Like if you look at a lot of people's ratings, it's either 4 or 5s or 1s. Like people either love them or hate them, is what you would conclude. But of course, in practice, a lot of people probably think they're okay and just don't rate. And so that makes people seem more divisive than they are. Right? The standard deviation, something we'll talk about later, is higher than it is. That's biased. But the average probably isn't. Right? As evidence that you use it. And it seems to work out pretty well. It's the same thing with Yelp. It's exactly the same idea with Yelp. Right? Yes, Yelp potentially has a self-selection issue, but it's not like people only rate it if it's bad or only rate it if it's good. And as a result, it seems to be a pretty good measure. But you know what Yelp is bad at? Grocery stores. How many of you ever looked up your grocery store on Yelp? I have. Apparently, all the grocery stores I go to are shit. At most I've seen like a rating of like 3 stars out of 5. Well, I don't think there's anything bad about it, but what's going on? How many of you are likely to rate a grocery? How many of you have ever considered rating a grocery store before? Let me ask you that. How many people have ever considered that? Right, virtually no one. It's never even crossed your mind, right? You use Yelp for restaurants, right? You can apparently use Yelp for everything. This is Yelp for like a section of 95, of like the 95 interchange. It's like there's a bunch of random things on it. Everyone sucks. Everyone hates it. If you had a good experience at the grocery store, that is so standard, it would not occur to you to rate it. If you had a bad experience at a grocery store, what are you likely to do? Rate it. And now all of a sudden, the people who have these strong opinions, not only are they strong opinions, they're strong negative opinions. And that biases the average down. I don't rate anything either. I think very rarely I rate something. But now I feel like I want to rate my grocery stores because I think my grocery stores are fine. I feel bad for them. Right? Everyone hates them. But now we have bias. Now we have self-selection bias. So you have to be really careful. You can't just look at the design and say, oh, people are opting in, therefore it's a problem. You have to ask yourself, are the kind of people who opt in going to cause this to be crazy, to cause this to be thrown off? Just because I'm selecting only this class to figure out what their favorite color is, doesn't mean I'm going to have a biased result. Because there's probably no connection between the major or the class and your favorite color. It's totally separate. Any questions? Let's do another example then. How many of you have seen Avengers: Infinity War? Right. Oh, it's a great movie. Right. What happens in that movie? What do you remember? Don't give any spoilers away. I don't care either of you. You both saw it. I'll do Michelle because yeah.
No spoilers, but it's a general plot. Like the main bad guy is Thanos. Control your voice, too. And
are you speaking?
I was speaking out of there. What does Thanos want to do?
So Thanos, there's these infinity stones that he wants to basically get, and those, I think it's like 5, I don't know how many, but they all have different elements, and those are control, there's 6, and all 6 of those, like, are, they were put together by when the galaxy began or whatever, and it's like he has all the things of power to basically control, let's say, time, reality, or any other factor. And it's essentially what he wants to do is like destroy planets, and that's his perception of basically how people can become more free is by them by committing like genocide, basically.
Not destroying whole planets. He doesn't want to destroy whole planets.
Not planets, but at least the people are like a certain population of them.
Yeah, in other words, not everyone, just half of them, right?
Yeah, and Infinity War is like it's one of the is the first part of the sequel itself. So, and then it's Endgame, and then the Avengers are and all of them come together to try to get all the stones and basically.
But so you summarize it really well, right? And the key, of course, is this idea that Thanos thinks there's too many people in the universe, and he wants to wipe out half of the universe, half the people, to make everything better. As an economics point, that's like totally wrong, by the way. But whatever, he has now read Julian Simon, that's fine. So, but let's talk about because that idea of being able to do it for everyone is something that he recently encountered. And before then, he was on this crusade to do it planet by planet, the quote-unquote old-fashioned way. And in that quote-unquote the old-fashioned way, he took an entire population, maybe in a city, gathered them up, and then randomly put them into two different groups, and then just murdered half of the group. Sorry, you guys all died. Murdered half of that group. Right? That's how he was doing that same basic idea. Apparently he's been doing it for a while. Let's imagine he did that. And so there's a group over here, and there's a group over here, and then this group he just murders. And then he asks himself, and then he asks everyone in this group that he did not murder, did you have breakfast today? He surveys them. Did you have breakfast today? Thanos. So he murders half the population. He asks the survivors, did you have breakfast today? Just as a hypothetical.
Oh,
No, he doesn't do that. No, he does murder half the population. But let's imagine he has a follow-up. Now I'm imagining. So imagine that after he murders half the population, he asks the survivors, did you have breakfast today? And then he says, oh, like 80% of them did. Now, can he conclude that that planet, before half the people were murdered, before he showed up, can he conclude that 80% of people had breakfast? Or does he have a problem of survivorship bias because he's only asking survivors? That's my question.
Wait, but it doesn't rely specifically on their survival because everybody eats regardless of their murder. That happened later as a consequence. So probably we know that everybody kind of needs to eat as a human. So the chances of them not eating breakfast proportionally to this other group would more likely than not be.
Well, let's be clear. So I like where you're going, but let's imagine this result was 30%. Does your answer change? Does your explanation change?
Like only 30%.
Yeah, only 30% had breakfast.
he just randomly killed them.
He just randomly killed half.
I mean, they're not mutually.
Exactly. Right. Remember, the survivors have to be different than those who didn't survive. If survival is random, then you just have a very murderous way to get a random sample. Right. A very bloody way to get a random sample. Did you have breakfast today? Then, assuming he really was random, and assuming that the people who sorted, like, there's no connection between, like, it's not like he went in the morning and then everyone who doesn't eat breakfast was already, like, asleep and they skipped over it, right? And they only got people who were eating breakfast. Imagine it in the afternoon or something. Did you have breakfast today? That is probably a random sample. Just because some people survived and some people didn't doesn't mean there's survivorship bias. Because there's no connection between if you survived or not and if you had breakfast. Right? The group that survived is probably not different at all than the group who didn't. Right? So just because there's survivors doesn't mean there's bias. Survivors are not different than those who didn't. Oh, I totally did who didn't twice. Sorry about that. Those who didn't survive. Right, any questions about that? Oh, I can do one more. I have time for one more. This one's a little harder. And then we'll close. So there's this great book about an epidemiologist who traveled to, I think it was Jakarta. And part of her job as an epidemiologist, does anyone know what an epidemiologist is? If I can say it, epidemiologist. Someone know? No, that you think of an epidermist or epidermal. No, so epidemiologist, maybe I'm misremembering, but an epidemiologist tracks diseases. You know, the epidural or
Epidural is,
is
anesthetic. I mean, I'm sorry,
it's the outer layer. I thought the epidural was the outer layer of the skin.
is the what?
It's the outer layer of the skin.
Pregnant women
Yeah,
that also get it.
Oh, get an epidural. Oh, I see what you're saying. You're right. Well, an epidemiologist
Is it
now is a different thing. Now I'm doubting myself. But let's just assume. So she tracks diseases, and so part of figuring out how to combat diseases like AIDS is figuring out how it's spread. And that and AIDS is spread two big ways. One is through unprotected sex, and one is through needle sharing. So naturally, she's talking to people who are likely to needle share. She's talking to drug addicts. She's also talking to prostitutes. And so the one of the questions is, how often do prostitutes work? How many Johns, their customers are called Johns, how many Johns do they service every day, and what kind of sex do they have? So the way that they do it is they go out to prostitutes, they find them on the street, and then they ask them questions. And the number of jobs that they do was way lower than what she thought it would be, right? In the process of her investigating and being in Jakarta, she's talked to many people, many people who work in this industry, many prostitutes, and based on these casual conversations, she thought they'd have many, many customers a night, but in reality, when they look at the data, it's a lot smaller. It's like super small. It's maybe only 2 or 3 a night. And she's like, well, what the hell? What's going on? And when she was talking to one of her prostitute friends about this, and the prostitute friends laughed and thought the mistake she was making was really obvious. Does anyone want to guess what that mistake is? What was going on? So again, let me describe to you how they do this. So prostitutes are usually on the street or on the street corner. And so the people who are working for her, people who are gathering this data, go up to them, with like a clipboard and ask them questions. They, about like, among other things, how many jobs you usually perform a night. What's the problem with doing this? Yeah?
Are they more likely to lie because they think that you might be taking data for like the cops or something?
Yeah, maybe, but then why would you say anything other than 0? I don't know what you're talking about, right? Why would she get anything besides 0? So maybe that's the issue, but that's not the real problem. Yeah, Michael?
Maybe if they're like out on the street, then they're not busy per se, so they don't have as much business.
Exactly. So they don't have as much business, right? The prostitute in question laughed at her and says, "You're talking to all the dogs, obviously. You're talking to all the ugly ones." Because the ugly ones will be happy to say, "Oh yeah, instead of working, I'm going to talk to this random person. I'm just going to like while the D's are, yeah, I'll just fill out this survey," right? Well, the ones who are busy are the ones who are working. They are not available. They probably not even be there at the time because maybe they're working. Or 2, if they are there, they're probably a little distracted trying to get work, right? There is bias in her sampling. By the way, this story comes from this great book aptly titled The Wisdom of Whores. Right. It's a really great book. My question for you as we leave, what was the sample bias that she encountered? So what kind of mistake, well, which one of these 3 things is a problem with? So it's partly under coverage. Why? Exactly. So some of them aren't there, right? Because they are servicing Johns. And so it's under coverage. But it's also self-selection, too. It's a little bit self-selection. Because if they are there, they're probably just going to say no. Because I'm busy. Right? And as a result,
you get a bad sample. It's sneaky. The whole point, it's sneaky, so you should be aware of it. Right? And in the end, that's all I have for you. So have a great couple of days. I will see you on Thursday.